can make your life a lot nicer if you come in and we can go through this and you can try and understand the unit circle. If I ask you right now, what's cosine of pi over 4, and you're like, I have no freaking idea, then you don't know your trig functions well enough to really be like moving nicely through the calculus sequence. You have to get comfortable with it. Cosine of pi over 4? Root 2 over 2. Root 2 over 2. Cosine of pi over 6? Close. That's sine of pi over 6. Root 3 over 2. So it's these sort of things that you want to be comfortable with. Again, save that for another time. We're just going to keep moving. All right, I'm ready for my equation, right, of my line. All right, y minus what? Y minus y1. What's the y1? This negative pi squared, right? It's weird. I understand I'm using weird numbers, okay, but pi is just a number, right? Equals, what's the slope? Negative 2 pi, right? That's what I just got. And then x minus, what's the x coordinate? Pi. The x coordinate, right? This one. That's it. I'm going to check our work here. I'm going to graph the function. I'm going to go to Desmos. This was fun. Let's do a new one here. New blank graph. I'm going to graph the original function, x squared, cosine x. There's the graph. And I was at the point pi negative pi squared. That should be somewhere. There it is, down there. Okay. You see where we are? And then we got the equation of the line to be y minus minus, right? That's going to be a double negative. Yes. So y plus pi squared equals negative 2 pi x minus pi. There it is. We have found the equation of the line that is tangent to that curve at that point. Yeah? This is fun? No? All right. Appreciate, well, I haven't turned them yet. I'm about to turn them. So, but we should be like honest with ourselves. At least we're not doing limits, right? Let's say y is equal to x squared cosine x over x cubed plus x plus 1. Okay, now here's where things start to get a little bumpy. What do you see? You see a product and a quotient. You see them both? Up here's, actually that's the problem we just did, isn't it? Okay, but see, that's part of a bigger problem now. That's just the numerator of a quotient. And so I need to figure out how to take this derivative. So what I'm going to do is this. I'm going to just look at this. This is my top function, right? This is my top, and this is my bottom. And I'm going to just write down the quotient rule, right? The quotient rule. The quotient rule says this. I need to take the derivative of the top first, right? So I need to write down the top, and I need to be able to take its derivative, right? Then multiply that times the bottom, which is all that stuff. Make sure it's in parentheses. All right, that's the bottom. What's the next part of the formula? Subtract, minus, now what? Derivative of the bottom, okay, that's the x cubed plus x plus 1. I need to take derivative of that. I'm actually not too unhappy about this part, right? Derivative of that, I'm like, okay, fine. And then I still need to multiply that times what? The top, okay, x squared cosine x. I don't need parentheses, but I'm just putting it there just to kind of really show derivative of the top times the bottom minus derivative of bottom times the top. And then all of this over, don't forget we're doing quotient rule, over the bottom squared. Okay, that's the setup, right? That's the setup. But now when you go to do this right here and take this derivative, you have to realize, shit, I've got a product rule there, right? This is a product. So when you go to do that derivative, you might need to come over here and do some scratch work and actually take the derivative of x squared cosine x, treating that product and doing what we just did, right? And when we did that, we got 2x cosine x minus x squared sine x. Isn't that what we got? Yeah. That's the previous problem. That's now just the top left corner of this expression, right? That right there, that over there in blue, goes right here. So my derivative is 2x cosine x minus x squared sine x. That's the derivative of this. Still times this. Ugh. Minus, then the derivative of this piece, which I hope you're all okay with, 3x squared plus 1, times the x squared cosine x without a derivative, and then all of that over x cubed plus x plus 1 squared. And that is my raw derivative right here. Yes?
Is it not plus
on the top left? Where, here?
Yeah.
Was it plus in there? No, it's minus. It was plus, but remember when we did the product rule, the derivative of cosine was negative sine. And that negative came out, yeah. Yeah, just go back. I did dot, dot, dot here because we already did this. Right? We already did this. So you see what I mean by turn the screws? Now you have a product rule that is appearing within a quotient rule. Wasn't that bad? I didn't say I was going to turn. It's slow. They don't just tear you apart on the rack. It's slow.
Yeah, we need better analogies.
We need better analogies? Is that what you said? Oh, that's funny. All right, let's try another one. All right, let me think about one. Let's do your triple one. Okay, so how about we do this? What if you have x to the fifth sine x, no, let's not do cosine, it's boring. Let's do tan x. And let's find the derivative of this. You have a product of three things now, not two, right? I never gave you a rule for having three things, did I? I said if you have two things, here's the rule. So the way we do this, and there's two ways you can look at it. Here's the way I'm going to choose to look at it. I'm going to look at it like this right here is my f, and it's being multiplied times this right here, which is my g. See, I'm looking at it, I'm squinting my eyes, and I'm seeing that it's actually two things being multiplied, right? Yes? So if this is my f and this is my g, then what would the derivative be? Derivative of that, right? Times this plus derivative of this times that. Let me write that down. It's the derivative of this times this plus, because I'm doing product rule, the derivative of the second one, right, times the first one. Can you all see that? That even though it's three things being multiplied, I looked at the first two together as one thing, and then I just wrote the formula out. Do y'all know what's going to happen now? Excuse me. Uh-oh. What am I going to do? What? What?
So are you just going to like separate it again?
Yeah, I need to take derivative of this, right?
Yes.
And that's a product. So I'm going to have to go do a product rule on this. Everything else is going to be, I can do. Derivative tangent I know is secant squared. So the only real additional piece of work I have to do is this left piece right here is a product rule. Maybe I need to go do that on the side, should we? Let's go do it on the side. I'll do scratch work right here. I need to take derivative. And on your work, I mean, do scratch work. I mean, do it on the side. Go figure out what it is. Look, if today doesn't make you go do scratch work, the next class will. I mean, you're eventually going to have to be doing some stuff on the side and bringing that stuff back into the problem. So get used to scratch work. It's helpful. Okay, so I'm going to put x to the 5th sine x here, and I'm going to try and take its derivative. So there's my product right there. Right, there's my product. And so I take, what's product rule? Derivative of the first one? Yeah, let's just do it. 5x to the 4th times, careful, sine x plus cosine x, x to the 5th. That's your derivative over there. That's your product rule on that piece.
Whenever it's like that, you want us to simplify.
How do you mean simplify it?
Or, I guess like just switch that.
This right here, I think it's a really good habit to put that in front of the trig function. And since we're going to wind up putting it back over here now, let's go ahead and do it. So we have y prime equals that answer. I need it all in parentheses. I need it all in parentheses because now I've created two terms over here, haven't I? The product rule creates two terms. And this tangent has to multiply times that. So if I were to simplify this, the tangent would have to go to both. And if you didn't put parentheses here, it would not go to both. So you have to have parentheses there. Plus now derivative of tangent, which is secant squared x, times x to the 5th times sine x. And that's it. I'm just going to leave it like that. How we doing? Fun? Fun, right? What section is this? Forgot what section we're in. 2. I don't know why I'm thinking we're in chapter 3. Product quotient. Oh, okay. Check this out. Check this out. Still have time. Now, we've been using this, okay? We've been using this, but I never proved it to you. If y is equal to tangent x, and I ask you to find y prime, you would just tell me the answer, right? The answer to this is just secant squared x, right? Because I told you, yes? But watch, we can actually prove it now. Because what I can do is I can rewrite tangent as sine over cosine. And now if I'm asking for the derivative of this, you can use the quotient rule, can't you? So the quotient rule on that would be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Do you all agree with that or not? Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. All right, what's derivative of sine? That I did prove to you, right? That I did prove. Using a limit, I proved that to you. So that's cosine x times cosine x. And then what about derivative of cosine? Negative sine, so that's negative sine x. And then I had a sine x there. All of that over cosine squared x, or cosine x squared. What's the numerator? Cosine squared x plus sine squared x. You recognize that? I'll write it this way. Okay, that's cosine times cosine, that's cosine squared. Minus minus is plus, sine times sine, sine squared. The numerator of this you should recognize from pre-cal as being the Pythagorean identity. Cosine squared x plus sine squared x is 1. And so this becomes 1 over cosine squared x. And cosine, 1 over cosine is secant. So this is the same as secant squared. So that's where it comes from. I'm just showing you where it comes from. From here on out, if I say what's derivative of tangent, you're just going to say secant squared. You're not going to go through all this. We can verify it that way. But we need the quotient rule for it. Okay, let me see, make sure I've covered everything here. I think you can handle all this homework, except one problem. So I've got time for it. Y equals x cosine x. Find so what does that notation mean? The 53rd derivative of that function. This is almost like I started class, right? Almost. When I started class, I wanted the 201st derivative of what? Just cosine, right? Yeah. What is this? X times cosine. So let's start taking some derivatives to see what happens here. So when I do my first derivative, I have a product, right? I have to do a product rule here. Are we comfortable yet with just doing the product rule kind of mentally? Can I do that and then you kind of follow it? All right, so when I take derivative of this, I do derivative of the first one, 1, times the second function, plus now the derivative of the second one, which is negative sine x times the first function, right? That's our first derivative. Everyone understand where every piece came from there? Clean it up. Cosine x minus, that x comes out front, x sine x. Okay, that's our first derivative. Let's take derivative again. Okay, you ready for the next derivative? What's the second derivative? Well, look, that's a subtraction sign, right? So can't I do these separately? Because there's a minus right there. What's derivative of cosine? Negative sine x. Okay, now be real careful here. Minus, right? Minus sign. Now, with everything else that remains, this piece right here, to take that derivative, I'm going to need to do what? A product rule. And see how I put the minus sign on the outside of this? That minus right there. Now I need a product rule on that. So let's do the product rule. Derivative of the first one. 1, right? Times the second. Plus, what's derivative of the second one? Cosine times the first one, right? X. Y'all see what I'm doing here? Derivative of this times this plus derivative of this times that. Yes? All right, let's clean this up. This is negative sine x. Let's distribute this negative through. Okay, isn't this also negative sine x? And then pass through again, minus x cosine x. Shit, we have to do this 53 times? Okay, this is going to be negative 2 sine x, because those are the same, right? Negative sine x and negative 2 of them. And then this right here is minus x cosine x. Are y'all okay? Hanging in there? We got to do a couple more before we see a pattern. We're going to see a pattern at some point here. Let's look at the third derivative. Third derivative. Well, again, don't we have two terms here separated with subtraction? Look at the first one. Do you know the derivative of 2 sine x? So I said 2. Negative 2 sine x. The negative 2 is attached to it, so I can ignore it. It's going to come for the ride. Derivative of sine is cosine. So I have negative 2 cosine x. Great. All right, that takes care of derivative of this. Now I have a minus again. Brackets. All right, now I need the derivative of this. Isn't that the original problem? Isn't that this? Isn't that this? And didn't we already take that derivative and get this? So I can just copy this, right? I've already done that derivative before. So I'm just going to copy that and paste it into that bracket. I mean, you can just do the product rule, but I've already done it. So I'm just going to put cosine x minus x sine x here. Following? This is a derivative of, right, we want the derivative of this, which is the same as derivative of that, which we did right here, which turned out to be this. Clean it up. Yeah? This is -3 cosine x plus x sine x. I don't think we have enough yet to get the pattern. I think we're going to need to go again. Any questions yet, though? Fourth derivative. Now, once I get to the fourth, I'm going to stop doing primes. I'm just going to put a little 4 in parentheses here. All right, let's look. We got a plus. I can do these separately. So on this one, -3 is going to come for the ride. What's the derivative of cosine x? Negative sine x, right? And that negative will hit that negative, and it'll become a +3 sine x. And then here, hey, wait, x sine x. Did we ever take the derivative of that somewhere? We did, right? Wasn't that right here? This piece right here, we took its derivative, and that's what's in here, yeah? So I can say plus, and then I don't need the brackets, but I'll put them anyway. The product rule on this was sine x plus x cosine x. Don't need the brackets, but this will become 4 sine x plus x cosine x. Do we have a pattern yet? Do we have a pattern? I'm going to write them down over here. I'm going to write down all our derivatives so you can see them. Here's the derivative, and here's the answer we're getting. The 0th derivative, which was the original function, was x cosine x, right? The first derivative was cosine x minus x sine x. The second derivative was -2 sine x minus x cosine x. The third derivative was -3 cosine x plus x sine x. The fourth derivative was 4 sine x plus x cosine x. Right? Yeah? Do y'all see a pattern on this side over here? It's just in terms of like this one, like in front of this is nothing, right? So we have like x cosine x, x sine x, x cosine x, x sine x, x cosine x, right? This keeps switching, right? X cosine x, x sine x, it keeps switching, yeah? Also, look at the signs in front. This one was a plus. This is minus, minus, plus, plus. What do you think we're going to have next? Minus, minus, plus, plus. Minus, minus, plus, plus, right? That's a conjecture, right? We think that's what's going to happen. We could probably do one more derivative. Let's just do one more. It's not going to take forever. I'm going to do one more derivative here. If I do my fifth derivative on this, then here's going to give me 4 cosine x plus the derivative of that I've done before. That was the original problem, wasn't it? So this gives me a cosine x minus x sine x. So when I put those together, this will be fifth derivative. I get a 5 cosine x and then minus x sine x. I know I'm going a little fast there, but So in terms of what's over here, it's x cosine x, x sine x, x cosine x sine x, right? Back and forth. And the signs look like they go, except for the first one, it goes like minus, minus, plus, plus, minus, minus, plus, plus. What about this? It just switches cosine sine, cosine sine, cosine sine. And the number in front is the derivative, right? And then what about the signs? Minus, minus, plus, plus, minus, minus, plus, plus is what's going to happen, yeah? Okay, this is going to require some modular arithmetic to figure out. We got to figure out where 53 is in this list. How are we doing? Let's try and make a conjecture here. The 53rd derivative, so far, here's what I feel pretty good about. 53 is in the front, right? Because the fifth derivative has 5, fourth derivative has 4, right? Sine or cosine?
Cosine.
Cosine why? Because it's odd, right? Cosines are on all the odd numbers. I think that's a pretty good conjecture there. Cosine x. Okay, can you make a conjecture as to which one of these we're going to have? Don't worry about the sign. Just, I mean, is it x cosine x or is x sine x? Should be sine because the signs are on all the odd ones, right? So I know I'm going to have out here an x sine x. So the only thing I don't know is whether or not this is a plus or a minus, right? And I don't know if this is a plus or a minus. Understand? I don't know that. And I don't want to count out 53 derivatives. So let's try and figure out when, let's look at the number in front. When do we get negatives? At 2, 3, right? And then we get positives at 4, 5. So these are switching every how many? How many does it make to go through a complete cycle? Negative, negative, positive, positive, right? 4. It takes 4 to go through a whole cycle. Let's mod all these in 4. Let's mod these in 4. What's 2 mod 4? This is going to be a tricky one for you. What's 2 mod 4? 2. 2 mod 4 is 2. Because when you take 2 and divide by 4, you can't. You can't. So you have a remainder of 2. What's 3 mod 4? That's 3, right? So it looks like for these two, if we ever get a mod 2 or a mod 3, we're going to be negative. Here is mod what? If we mod these, we get mod, so these we get mod, the mod will give us 2 and 3. If we mod 4 with these, we're going to get what? 0 and 1. And that'll give us positives on the front. Y'all following that? What's 53 mod 4? Hold on. 53 mod 4 goes in there once, 4, 0, 3, 1, goes in there 3 times, 12, 1. We have a remainder of 1, right? So 53 mod 4 would give us a remainder of 1. So that means we're in one of these, right? Which means it's positive in the front. Question? What? Comment? Yes?
So is there a word to describe the number before the mod and after the mod?
The number in front.
So you know how like in a fraction you describe the top number as the numerator, bottom as the denominator? Like,
I don't think there's a name for it. I'll have to go back. There might be a name for this number and this number. Really, it's more of what is the operation, like what is it that's actually happening. I'll have to double check. I don't think there is. It just this has to be an integer and that has to be an integer, and that's pretty much it. Yeah. Okay, we've taken care of this part. What about this back part? This was it's a little different pattern, isn't it? The pluses and the minuses are happening in different places. So the pluses are happening whenever we're what, mod 3 and 0? 3 and 0 is where we're getting this. So this happens when we get mod 3 or mod 0. And these two are happening where we have either mod 1 or 2. And what are we? We're mod 1, so it's got to be what? Minus. It's got to be a minus. This is, I mean, this is a, this is why this is, I believe, the last problem in the homework assignment, I believe. But now at least you have a framework of how you could do it. I'm going to just look at the homework just to make sure you can handle all this. I think you can. Product rule, quotient rule. 36. Oh, it's not the last problem. It's actually, I didn't even assign it. What the hell, Robert? I'm looking at this. Yeah, so you're going to have some fun with some of these. I would say let's stop at 30, 35. So don't do those right there. Stop at 35. And since I'm asking you to not do those, do number 36 as well. So that plus 36. So do 36 here. Okay?
Was it number 1 on those that said something about finding the normal line? I think I had to look at this one.
Nobody's asked me about normal line in here, except some people came to me in my office and asked about normal line. So on your homework, it asks you for the equation of tangent line and normal line. All a normal line is the line that's perpendicular to the tangent line. Okay, so let's say that you do a problem. Yeah, so let's say you do a problem and you have this tangent line, right? And let's say you come up with this tangent line has a slope of 2, right? And you have the point. You know this point. So you come up with from this you come up with the equation. Got it? The equation of the normal line is the line that would go through like this. And shit, that's terrible. It's supposed to go through that point and be perpendicular, right? So the slope of this line would be the opposite reciprocal of this number. So whatever this slope is, that's 2 over 1. You flip that fraction over and you change the sign. And then you use the same point and you create the equation. Okay. So all it is just the,
Gotcha. Okay.
got it? Opposite reciprocal. Opposite mean change sign, reciprocal mean flip over. Normal line should just be like the perpendicular or orthogonal line. All right, everyone. Come back Thursday. Thursday? Yeah. Thursday? Today's Tuesday. Thursday, we do the chain rule. The hardest rule is chain rule. But practice this. You got to have this down first. Good day, everyone.
I went ahead and already turned in 2.4. I thought we had to do that.